All right, let's get started. Hi, everyone. Thanks for coming to our conceptual design review. This is what we have so far, week 4 by the mock comp team. All right, let's get started. So first off, the rules of this competition. We have 2 flying missions. The first one with no payload, just a naked airplane. Does it fly? That is the main question. If we do fly, we get a point. If we don't, there goes our competition. Second mission is our delivery flight, is the big kind of main event. We carry our payload inside and we try to see how fast we can go and how much we can carry. And yeah, we get scored on those things. And also we have our ground mission where we get the plane on the ground and try to load our payload into our plane and get it ready to flying as fast as possible and get time. And that is our score. And Preston here will tell you how those scores add up.
Yeah, so Peter mentioned the scoring based off the independent missions, but for the overall score, it's going to be computed from the written report score, which is the report that basically is going to summarize all our research and testing, as well as our manufacturing. And then it's going to also include the flight mission score, the ground mission score, and the rated aircraft cost using the formula below. So this formula calculates the overall score. The flight mission score is the product of the 2 flight missions, mission 1 and mission 2, multiplied together. And then the rated aircraft cost is the empty weight plus the battery weight. So those 2 factors go into that overall score as well, which is shown by that first equation again.
So for the methodology, the general methodology we used for our numbers came from a mixture of optimizing for score and then also some assumptions we made based on what would be realistic. So the first kind of general process we used was using the sample script code to find the highest score for each weight in an iteration from 1 to 55 pounds. After viewing the scores that the code gave us, we ended up deciding that 8 pounds would be the most realistic while still giving us the highest score possible. And after we made the assumption of 8 pounds, we were able to iterate through a combination of aspect ratios in order to find the most logical values that, again, still yielded us the highest score. And then finally, once we had those 2 numbers picked out, we were able to backtrack through the different matrices that were produced by the MATLAB code in the sample script. And we were able to find the wing loading and power loading values based on the position of those 2 values in their respective matrices. And then with an aspect ratio and weight selected, we were able to pretty easily calculate all the other values. The number of crates came from a percentage of the takeoff weight and the volumetric size of the Jenga blocks. And then things such as top speed, turn, load factor, coefficient of lift all came from general equations and functions in the sample script, as well as just equations that were provided. And then this graph here is our aspect ratio versus score, power loading, wing loading, lap time, and takeoff distance. And so we use these graphs to best determine our aspect ratio, and we determined that an aspect ratio of 6 gave us the most reasonable power loading and wing loading while still giving us the highest score possible. And so we ended up using this analysis to determine that 6 should be our aspect ratio.
So this is the overall configuration of our aircraft. We went with the low wing with no dihedral for ease of construction, and also no taper for ease of construction. And that way we could have the fuselage have the door on the top so that we could load the containers without having to flip the aircraft over or deal with any complicated mechanism, and that we'd have a large target to get them into, so we wouldn't have to line them up carefully with anything to speed the ground mission. We went with a conventional tail because we couldn't think of a compelling reason to use any other layout, and that's what there would be the most experience and data about. The landing gear here is shown as a tricycle gear, but that's not finalized and could easily change.
Yes, this is our payload. It consists of 3 containers. The containers on the left there, modeled in ratio by a chapstick. We'll have 3 containers, each holding 15 Jenga blocks. The containers will be 3 inches by 3 inches by 3 inches. Our total payload will be the 3 containers in a line. And by the rules, they have to be a 1/4 inch apart, with an air gap, which could be like foam or just a 1/4 inch space between the containers. So we calculated that to be about a 10 inch by 3 by 3 necessary bay for housing those containers. And then for loading the containers or loading the Jenga blocks into the container, we're going to have a stack of the Jenga blocks preset, and then we're going to slide the container over those Jenga blocks and then figure out a way to close the lid.
Some aircraft figures. We optimize the aspect ratio to be 6. We calculate our wing area from the aspect ratio and wing loading to be 3.63 square feet. Our power will be 487 watts. Our takeoff weight, which we chose based on what's realistic and what's going to give us the highest score, is 8 pounds. Our calculated wing loading is 2.2 pounds per square feet. Power loading, another value that we found, is 23.4 roughly pounds. Our top speed that we assume we're going to be traveling at the whole time is 74.832 feet per second. Our load factor is 7. Our takeoff distance, which we maximized for, is 0.6504 feet. Cruise coefficient of lift is 0.3312, and our turn coefficient of lift is 5.207. We will have 3 containers, each container containing 15 Jenga blocks. Our time target for mission 2 is 10 seconds, and our rated aircraft cost is 4.8. And from all this, we calculate that our score will be 99.171.
Actually, wait, a comment on that score. That score is also multiplied by our report score.
So like, what did you assume for the report score on that?
Like 1 question mark?
Okay.
Yeah,
Well,
we
didn't
scored full points. It's either a 1 or a 0. Or whatever they give the written score as, we will multiply that times whatever score we have, whether it's 0 out of 1, 0 out of 100.
Okay.
Yeah, since the written score isn't something we can influence in the design, and since it's multiplying the overall score, we can essentially ignore it at this stage.
Okay, sounds good. Yeah, I guess Becca and Jake, do you guys have any things you wanted to mention off the bat? Okay. Well, I've got a couple questions. If you want to go back to those plots. Okay. So I'm looking at that score versus aspect ratio plot, like the second subplot there. And it seems to me like there's a score optimum at like as you decrease the aspect ratio. And so I'm wondering why you decided against doing like a lower aspect ratio.
So the problem we ran into initially was that the code was giving us some pretty wacky numbers for power loading and wing loading. And so if you can see on that first chart there, the wing loading doesn't vary too much with the aspect ratio from the model we used, but the power loading did. And so just based off reasonability, 6 as opposed to anything lower, you get a drastic drop off in power loading, which didn't make much sense. And so we faulted that with either an error in the model or an error in our methodology. And so for us, In addition with the lap time too, before lap time, or before an aspect ratio of 6, the lap time jumps up very high. And so we determined based off those 3 factors that 6 would be the most reasonable choice, including the lap time, the takeoff distance, and then reasonable values for power loading and wing loading.
Okay. Okay. Do you know? I wonder why that, like, on the lap time, that there's such a big discontinuity there. Do you have any thoughts on why that is?
My assumption would be that it was from the wacky numbers we were getting for power loading and the amount of power we would need to pull the weight we had, and I'm guessing that messed up how long it would take for it to go around the course.
Okay. Thank you. Yeah, and then I also had another question on the takeoff weight. You said that was like 8 pounds, right? Okay. Yeah, I think you said something like it was the most realistic, like, takeoff weight. I was wondering if you could elaborate on what kind of you meant by that, or how that decision was made.
Yeah, so I think we took into consideration our payload of being 3 containers, about 1 pound. We also have to take into account, like, our battery is going to weigh a little bit, our airframe is going to weigh some, our electronics are going to weigh some, and we thought that for because as you decrease the weight, you increase the score quite drastically. We felt that 8 pounds was our like a practical score, or a practical weight, because if you go any lower than that, we were kind of worried about wind and how that might affect our flying of a lighter plane. So we think that 8 pounds is like a good sturdy estimate for a solid plane.
Okay. Okay, sounds good. Let's see. Oh, also a question for Andrew. I was looking at the like mock-up you had of the containers.
Yeah.
I was wondering what you were thinking as far as, like, the material for the actual construction of the containers. Were you thinking like a cardboard type of thing, or did you have other thoughts on that?
No, I don't think we're thinking cardboard. I think we'll do something pretty lightweight, because we don't have to. We just have to contain it into the shape of a cube, because they will be in the plane, and so they don't have to be as structurally stable as other designs we had. So we haven't really decided what material they'll be, but we know it's not going to be a really heavy material.
Yeah, I think we were going to solve that problem in detail.
Yeah.
Okay. Yeah, okay, that makes sense. And then I think the last question I had is that that turn CL was very high. I was wondering if you had any thoughts on like, why that number is so high, and if you're going to try to implement anything to be able to achieve that, because that's a really high turn CL.
Yeah, so it's actually, that's the turn CL based off capping the load factor. So the code that we used produced a load factor of 12. And so our turn CL was closer to like 8, 9, or 10. And so after talking with Becca and talking as the group about what would be more realistic, we decided to artificially cap it at 7, because reasonably we couldn't imagine the load factor ever going above 7, which still might be on the higher end of estimating the load factor. And so based off of that load factor, the turn CL, that's the turn CL we got out of the lift equation. We briefly talked about like structurally what we need to implement for that high of a turn CL, and it probably will go into account with our airfoil and everything, but we don't have 100% concrete plans for how to implement it as of yet.
Okay, so was that the turn CL calculated at a load factor of 7 at your top speed?
Yes.
I think,
Or
okay,
at the turn speed, sorry.
at the turn speed.
Yes.
How did you calculate the turn, or like, what's the turn speed?
The turn speed,
Thomas, by the way, you muted yourself.
Oh, sorry. Let me just if you have any other questions, I'm gonna go into the. I don't think we wrote it on a thing, so I'm gonna have to go into the code and look at it, but I can get that in the next minute or two.
Okay, thank you. Yeah. Oh, I guess I did have another question, but I don't know if Beck or Jake have anything that they want to ask.
What's a sample code script?
So again,
I was just wondering what a sample code script is because I've never heard of that in industry before.
That was just the code that was given to us, I think, by Laird. And we were just using that to calculate all the optimizations and stuff that Thomas did. But I think that sample script code was given to us, I think.
So it's a script that does like some optimization.
Yeah, it was just like, it just like plugged in some numbers and like showed us how to use, like what inputs we needed to get certain outputs and stuff like that. So it was just to like show us how to use other functions.
Yeah, and based on what Preston said, the code we were given and used had a list of functions, and then those functions were being called through just a script called sample script, and then we developed other script files that through the sample script called upon those functions. So the sample script could output certain things like the turn speed, the load factor, all of that, and so we used it as needed to pull that information into our own scripts.
Any other questions? Laird, I know you had one.
Oh yeah. I also wanted to ask, like, that 10-second ground mission time.
Mhm.
Did you guys do any like kind of like physical testing or anything on that, or do you think that's like a realistic number, and where's that from?
We kind of like talked about that as a group, and just because based off our design, how we don't have to flip the plane over or anything, and how it's just going to be like a flap door almost, or we haven't decided what's going to hold the boxes in. But basically we kind of just like, I mean, Peter was on his desk and I think he was just like taking stuff, putting something in, taking it out, just kind of like stuff like that. But I think just as a group, reasonably, we decided that whoever was going to be conducting the ground mission could do that in 10 seconds.
Okay.
Yeah, like everything is as conceived there is designed to be very quick to operate with not having anything have to be precisely lined up and having everything latched together such that you essentially just slam a door closed and it stays.
Okay. So it's like do you have like designs for how that's gonna, like how you're gonna snap things in, or like how it's gonna stay in place, because you don't want things to like shift around and stuff while you're flying?
Not yet.
Okay.
I mean, what I was thinking of was something along the lines of like a wedge that pushes something to the side and then it snaps over it, like
some kind of like compliant mechanism.
Yeah, some sort of fairly simple compliant latch, but
cool.
We haven't discussed and settled on anything.
Yeah, going off that, I know Becca mentioned like tape is something that can be used, especially just because that's also lightweight. That won't add any weight to the plane or add any like complications. She also mentioned like a piece of like cloth or something like that was like super thin, but also like pretty durable, that we could just like kind of put over the top of it. That was like a piece of tape that could just hold that payload in place.
CA hinges.
Yeah.
Okay, cool. Yeah, I was gonna say, because as far as tape, I feel like, wouldn't that affect your like unload? Because unloading is part of the ground mission, right? You have to unload the containers.
Yes. Yeah.
Okay.
Yeah, and so whatever method we use would also be quick to get undone. In the compliant latch suggestion, you would be able to push it in and it would unlatch.
Okay.
And then Laird, I have the turn speed.
Okay.
So it came out to be about 50.06 feet per second.
Okay.
And so if we need to play around with like the structures, and if that's too high of a load factor, we can always play around with that speed and manipulate it to be a little bit more reasonable if we need to.
Yeah. So what I would consider doing is, because I think that like aerodynamically a CL of over like 1.3 or maybe 5 if you want to have like some crazy flaps or something. Like sorry, 1.5, not 5. So what I would do is I would set like a maximum turn CL based on some airfoils and stuff that you look at, and I would try, and then you can use your load factor of like 7, and I would try to like recalculate a turn speed at that condition, right? Because you can solve the lift equation for velocity,
right?
If you have the load factor and the CL and stuff. And then I think you could justify saying that you like cap your turn CL based on some airfoils, especially now that you're getting into that side of it with Jake and stuff. But yeah, 5 is quite a high number there. But
okay,
yeah,
It's a little big.
So you said to keep it between 1.2 and 1.5.
I would say 1.5 would be hard to do.
Okay.
Remember how you can look around on the website for airfoils, see how high of a number you can find, because it won't be very high.
Yeah, no, it was like barely going above 1.2 sometimes. So
yeah, no, I mean 1.5 I think would have to imply like you would turn on like a high lift device, like you would engage your flaps in a turn or something.
1.5 is god tier CL.
Yeah.
At max AOA, so
yeah. But yeah, other than that, that's a good presentation, guys. I'm very happy with the work you guys have done. Like this has been a good quarter so far. So yeah.
I guess I'll go with my questions.
Yeah.
So I've already forgotten everything. So y'all are saying like half a foot takeoff distance. So I was thinking that you would wouldn't you need like a pretty thicky area, like wing area to take off, because that's like incredibly short. Particularly like when you're spinning up your motor, you're also not at full power yet, you know? And so you're saying not only can you take off, like that's how fast you're accelerating. So you're spinning up the motor and accelerating the plane is that time that you've narrowed down to like 7 inches.
Well, if we have brakes, we can probably spin up most of the way before we start moving.
I don't
Guess
think
how many DBF planes have had brakes so far?
Well, this can be the first. It can't be that hard. Like they don't need to work while it's moving.
So we have before, I don't know, was it the 2019 competition with the ramp? I think you could hold the plane as it spins up, right?
Only if it's explicitly required by the rules, though, which it was in that year.
It was required, but
yeah, you had to hold the plane until you were at full power, and then it had to be released. It's to simulate a cat launch.
Sure. Yeah. So I'm kind of concerned about how short that is. I don't know. So when we like yeeted it up like really quick on that video we took, does anyone know like what our minimum
I think
takeoff
it was
is?
about half a foot. I think it was pretty close to that.
Really?
Yeah.
I would have think it was even like a little bit longer than that.
I mean,
but still, that was like kind of crazy. And we had like a really big wing area, and we had well, we had the fences. There were pretty big fences to get some. So I'm wondering, like, I think your wing area is smaller than we had, and so far you haven't talked about any high lift devices, and I know you're not in detail yet, but conceptually, I think you would say like what is like, did you calculate that number? Where is it from?
So, I mean, I didn't do the calculation of it, but one thing I will say is that I forgot the high lift devices. But yes, we have discussed having flaps and possibly slats.
Mhm.
So the actual value that we calculated came from the sample script that Laird provided us, based off all the parameters we put in, like the aspect ratio of 6, the wing loading, everything. The sample script gave us back a takeoff distance of 0.6504. So I think that was based off the sample script, just what we set our benchmark as. But obviously, it sounds like we can maybe artificially add some to it if we need to, based off like what we know to be reasonable.
So I feel
Was
like
that? Mm.
I feel like everything that we're saying, like all the sample script, it might be Laird's fault. I mean, you never
I think
know.
that it might be. It might be. Well, yeah. So I will say, like, on the sample script, I would encourage you guys to look into the code in the sample script. So if you get some weird numbers, like, or like if you're getting some weird numbers, like, go in and see, oh, it's getting this weird number because it's getting this other weird number, which is coming from this. Okay, why is that doing that? And like, I'm always happy to like help you guys with that stuff as well. Like if you're like, I have no idea where it's getting this number, I can like walk you through that function and stuff as well. I know this is kind of like the ending point of even using that code because we're going into preliminary and stuff at this point, but if you are interested in like re-examining some of those numbers, like I'd be happy to walk you guys through some of the functions in there in more detail.
So was that calculated then with that? Well, you have your cruise CL and your turn CL. So what would be what's your coefficient of lift on takeoff? You also didn't specify like a ground alpha, which is, well, I guess that's going to influence your airfoil design. So maybe you don't need to know that yet.
I can speak to that a little bit. I know that the sample script does calculate, so it uses a more or less in like data driven model. Like it doesn't calculate a lot of parameters. It just like it uses a fit model for wing loading and power loading to takeoff distance. So it doesn't, that model won't actually calculate a CL. So it is possible that it would not be a possible takeoff distance. I don't, depending on whether the input parameters fell within the range of that model. Is something to
Where
consider.
did that model come from?
It came from DBF data. It came from DBF data. So it's like
previous years.
What's up?
So this is just like within the realm of planes that could be created. This could happen. So that could mean that you do throw in high lift devices because the model could have been based on aircraft with high lift devices. Is that how that goes?
No. It was not based on anything with high lift devices. It was calibrated. It was calibrated using just like a standard rectangular wing DBF style plane. And they made a bunch of prototypes and got the takeoff distances and stuff.
Is it based on wing area?
It's based on wing loading and power loading.
Okay, sure.
Yeah. So it is a potential weak spot, but it also isn't like arbitrary. It is backed up by testing and stuff. So.
Okay.
But if we were doing this IRL, my first thing that I would have said is, you guys should test that. But yeah.
Certainly. So in the drawing, I would have liked to see more dimensions and specifications on that. Like you fit the payload in, you know the dimensions of the payload, but that's not on the drawing, right? So I have So are we thinking like that's
Get a scale rule.
huh?
Get a scale rule.
Oh, you're telling me that it's based off of the squares? You didn't put a legend.
Why would I put a legend? We told you how big the containers are. You can figure everything out from that.
Well, sure, I could, or you could say one box.
Some of us are incapable of figuring anything out.
Well, here's the thing. It's not based on the squares. It's based on my ruler, which unfortunately is on my desk, not on the document.
It should be based on the squares. That's what the squares are for. Anyhow, all opinions aside. Okay, so yeah, if you say that that's to scale and everything, that's cool, I guess.
But also
Yeah,
there's
maybe-
just a limit because to how to scale we can be, because I don't think we ever sized the 10.
Also,
Right.
just so we're all clear, that's not the actual size of the plane. I don't know if we. Yeah.
Well, the span and corridor, according to the figures listed. So those are correct as of when I made the drawing. And the
Sure.
size of the boxes are correct as of when I made the drawing.
We didn't have a wingspan limit this year, yeah.
Yeah, that's correct. But
No, we did. It was
I
10.
think it was
Yeah, it's 10 feet.
Sure.
But
Yeah.
what? Because you have to fit inside the box.
well,
Right,
isn't it
this
longer
is-
than 10 feet though? Because it's a 10-foot square box.
Yeah.
So you can
I've
take
also
the
had this
diagonal.
thought,
It's okay.
but
Unless the entire plane was just a wing and you had 100 square feet of wing. I mean, I guess that's your limit. But in terms of length, it'd be 10 feet. In terms of
Laird, don't you have to be in the box with the plane at some point?
yes.
Well, that's
So-
why we make the landing gear long enough that we can fit under it.
yeah,
So 7-foot gear, 100 square foot wing.
geez, Jake.
Well,
so you
no,
gotta
we like
find
crawl
out the
around.
box.
We don't need 7-foot tall gear.
Why do that when you can just build like a hover jetpack so that you can just sit over the plane and work on it, and then don't bother mentioning it when the other team's like, "What the hell are you doing?"
It might melt this
Well,
time. No.
Here's the worry with that though. There's going to be some significant amount of downwash, especially
Not
if
if
the
you
rotors
design
are
it correctly.
small and therefore have to be high velocity. And I'd be worried about that damaging the plane. Because it's going to be extremely lightly built to get a 100 square foot wing in the 55-pound weight limit.
Just make it a sky crane that has like 100-foot cord that you're hanging from, and then it's anchored over the what's it called?
You know,
the
that
box
might
thing.
actually work.
The downwash will have dissipated.
Y'all really love a tangent. So I guess as a
But you can make the plane a lowrider.
as a reflection by y'all, does anyone want to speak on maybe like if you have anything to say about what parts of your model and your design you're like most confident in, or things that you really wish you could test, or things you want to look back on and like revisit that, you know, like what are some weak points and strong points in your analysis?
Yeah, I think the takeoff distance would be a really good one to revisit because that has a huge impact on the score, the way it's calculated. And since we have such a small value for our takeoff distance, just any small change in that would be very big to our score.
That would also be one that we could also test if we were in real life. That which would be really beneficial, but due to circumstances, we can't do that.
Yeah, I feel like there must be some way to figure out like how quickly it takes or how much time it takes for a normal, like, I don't know, 546 motor or whatever to spin up to max RPM or something.
Laird.
Yeah, if you guys want to talk about that in the propulsion side, I haven't actually done a ton of prop analysis on like takeoff conditions and stuff, but we can look at that. It shouldn't be too hard to model some stuff. And at minimum, even even if we don't model, because like the motor does spin up pretty quickly. So, but even if we don't model that part of it, we can still model, like, assuming full thrust is this a feasible takeoff distance if you get like a CL and stuff that you're taking off at. Like that modeling can be done for sure.
I mean,
Yeah.
spin up's a real easy dynamic problem too. If you have like your torque speed curve, when you're just kind of like.
You're right.
inverting
You're right.
and you
Spin
like,
we
motor and shit.
yeah,
And
the
then
model.
tracking like how far your plane's moving during that spin up.
Yeah. No,
You're in dynamics, you can do it.
I have done a before I was in dynamics, I tried to do an analysis of that and it was fine. So I could probably do it better now.
Good one. Yeah, I did a
Yeah.
flywheel and we had like spin up, spin down, and impact floating and everything. So
Yeah, so would we also be able to do like an analysis of high lift devices for takeoff?
That's a Jake thing, but yeah. Like,
and how much of a chance would we have at keeping the plane still for at least part of the spin up? Like my brake suggestion, is there any way to actually make that work?
brakes are kind of complex.
You could have a tricycle gear, and you could have like a servo and like a little piece of wood, like a bar across both the back tires, and have friction braking instead of like a
Yeah.
more complex system. But I don't think
Drag.
Honestly, you could just poke the tire with a stick, because it doesn't have to be a brake you can apply while in motion.
Just make retractable chocks.
Are we
Jake,
allowed
did you-
to like have an anchor attached to like a cable release?
As long as you bring it with you.
Well, that screws up the whole thing.
I don't think brakes would work for the tail dragger, because you can't really have it on the front two wheels, or else you
Well,
just
you'd just be risking falling
Yeah.
over.
Depends on your gear geometry.
What do you mean?
I mean, you can make any gear geometry you want, and if you make it steep enough, then or I guess not steep enough, then the motor at max power won't tip the plane over, because that moment won't be greater than the CG moment around the wheels. But you could also not do that and make it so that you're like most scale tricycle gear planes have plenty of power in the engines to tip the plane over the brakes.
Got it.
But that's up to you.
Another thing on your performance summary slide, it says time for mission 2 is 10 seconds. Y'all mean ground mission?
Yeah, that's a typo.
Right, sure. I just think I've seen y'all call it that like a couple of times. But like in DBF, it's very standard. Like ground mission is like GM, and then there's like mission 2, mission 2, mission 1, 2, and 3 for different things. And so here you just have like a ground mission and mission 1, or I guess you have mission 1 and mission 2. Proof of flight.
Not being scored on the time for mission 1. You're just being scored on the time for mission 2 and your ground mission.
Hey,
Yeah.
Laird, how long is a flight lap?
What do you mean? Like distance wise?
Yeah, as an estimate.
Well, it's 2,000 feet straight legs. We often, if we are trying to do bad ballparks, we will assume 2,600 total, but
How many laps are there in mission 2 for this?
3.
Right. So there's also nothing mentioned about like cruise velocity. You mentioned, is there? Did I just
Yeah,
miss
there's
it?
something
speed.
about
I
cruise
thought it was
velocity.
somewhere in there.
Yeah.
Or maybe it
performance
wasn't in there,
stats.
but someone mentioned it
Well,
sometime.
you're talking.
What
Oh,
was
sure,
it,
top
the top
I
speed?
see. Yeah, okay, I'll believe you. Usually I think we talk about lap time. And lap time has no meaning to me, but it probably has meaning to somebody.
Yeah, I would have included the lap time on here as well, but or just like a total mission 2 time, in addition to the total ground mission time, which is currently in the mission 2 spot.
I mean, if you guys want to fly your mission 2 in 10 seconds and go Mach 0.7, I encourage it, but then we're gonna have to get back to talking about sweep for the wings. So,
Well, honestly, I'm more concerned about the propulsion there. Like, how well can you make a ramjet powered by burning lipos?
very well, since lipos never go out once they're on fire.
It's true. I don't know if that's
And
forbidden.
if we do, how long will we be banned from DBF competitions?
Yeah, I mean, Laird, they say the energy has to come from the batteries, but like,
They don't say how. Yeah.
Yeah, exactly.
And when you land, you just like smash it into a giant sand pit to put it out.
Well, the idea is that we use all the energy while we're flying.
Or the USC van, and then it works out either way.
Yeah, so generally y'all should like yeah, all of the questions that we ask, ideally, we wouldn't have to ask too many questions, like and also there were speaker notes that y'all missed, like about the like load factor. There were speakers notes that y'all didn't use. So just make sure to like have all of the important things, and like also your plots are kind of messy and not very clear. So I mean, yeah, it's not like a big deal, and I know you're not presenting to like professors or anyone important, but yeah, trying to be really clear with your presentation and try to minimize the like silly questions about like, oh, was there velocity and stuff like that. But
also name your code things that actually make sense.
Okay.
that was Laird, and then nobody changed.
Yeah,
so
I mean, if I can roast Laird by roasting other people, then it's even better.
So here's the thing. I've been kind of biting my tongue because it's been funny for me. But the sample script was a sample script. And it is totally fine. It is totally fine that you use that infrastructure and turned it into a function. I was amused because like like what I would have done personally is I would have copy pasted the stuff from the sample script that you wanted into a different thing. Doesn't matter either way. The code works the same, but I was amused.
We do not disturb existing infrastructure.
Fair enough. Oh, and to be fair, there was a lot of poorly named code in the DBF archives.
It's because of you.
No. I only do that on my own computer. I only do that.
Oh, really, Laird? Why is there a copy of my airfoil design function called airfoil design poop?
There is. That is true.
Dropbox.
In the Dropbox. Not only that, I sent it to you as like a, hey, here's this.
And now every time I want to go show someone the airfoil design thing and it's in the Dropbox, they get that. And it's great. Yeah.
Okay.
It's greatly appreciated.
Touche. So.
I'm done with my comments, questions. Jake, you have to contribute.
I think I'm supposed to be eating or something, so actually
not committed.
Hey, at least I showed up unlike some people whose name starts with a J and end with an Ani. He's probably doing something important.
He's in Universal Studios Orlando.
Yeah, sounds important. Anyway, I don't know. I mean, at least it looked like a design review presentation. Good job.
Did you appreciate our CAD model on the title page?
You mean your favorite friend, the C-119 boxcar from the movie Planes, Fire, and Rescue?
Yeah, he's our friend.
I hope you guys have the film rights to that, because otherwise Disney's gonna come knocking.
Just don't have to get caught, and then we're good.
This one was pretty short, but in the future, anytime you go through, or well, not anytime, but like when your presentations are like upwards of an hour, again, this one was pretty short, but if you've just finished like a fat stack of information, that's usually a good time to ask for questions, because like it lets people process and stare at it a little, and like maybe come up with something. But even if they don't actually ask anything, it's like a mental pause for a little bit, instead of continuing to smash the information out.
So you're saying it's a way to pause without anyone being like, why
Yeah,
the fuck are you pausing?
without being like, all right, so everybody wait 1 minute. Plus people could very well actually have questions about something you just said, but they're like not saying it at the moment. So yeah, you can still throw those in there for the looks basically, but understandably when your presentation's like less than half an hour, it's not that necessary.
Oh, also is the 10 seconds loading and unloading? Because I wasn't aware that unloading was timed.
It's both. It's the total time for the entire ground mission.
Yeah, y'all should really test that. I think it's Jenga blocks such that y'all could test that.
We get a pause in between the loading and
Yeah.
unloading, right? Yeah, okay.
Yeah.
And for unloading, we can literally just dump the containers out of the plane and then we're done, right?
I'm sure if you want to flip the plane over, you
Is it
know,
that heavy?
basically breaking your plane.
I mean,
Yeah.
I haven't been pumping iron, but
It may not be heavy, but it's still big, and
Yeah.
it can be big enough that it's actually hard to maneuver around, especially
you're,
because
like,
it has to
spinning
stay in the
things.
box.
And
Yeah,
you
I
don't
would think it
want
would be
to-
easier to just pick up the containers and, I don't know, toss them at USC fan or something.
Hmm.
I was getting it.
Bold of you to assume that they're fans and not only DBF members of the competition. It's not a football game.
I think he said Van, Becca.
Oh,
I'm sure. Yeah,
Yes, I did.
he was getting on board. Although you can only do that the last time you're on the ground mission, because you might not get them back.
We're
Well,
probably
I mean,
recording.
presumably we'd be tossing the contents, and that makes it Laird's problem to replace the Jenga blocks.
Indeed. All right. Yeah, I mean, is there anything else from anyone?
Is detail starting? Ah, shit.